Hi, in this module we're going to take a look at how to create a spreadsheet, how to use a spreadsheet, and we're going to be using Microsoft Excel. So I'm going to launch Excel from my quick launch toolbar, pointing at it right now, and when I do, it presents itself in this fashion. What's immediately apparent is there's a large grid area. And that grid is formed by the intersection of rows and columns, and you'll notice that the columns are labeled with alphabetic characters across the top, and the rows are labeled with numeric characters down the left side. And everywhere a row and column intersect, you have a storage unit that's very fundamental to using spreadsheets. You have a storage unit called a cell, C-E-L-L. And in cells, we can store things. We can store text, we can store numbers, we can store computational expressions, and then there's some other things that can be stored as well that aren't used all that frequently, but nevertheless, from time to time are extremely handy. We can store audio clips, video clips, hyperlinks, and so in this module, what we'll focus on is the fundamental things of how to construct a spreadsheet where we store text, sometimes known as labels, numeric values, sometimes known as values, and also computational expressions of two different varieties, the type that are built into the spreadsheet program known as functions, and the ones that we craft ourselves called formulas. So what I'm going to do is create a example that should be easy to relate to. So I'll try to use a simple example in showing the features of spreadsheets so that I'm not overly complicating things. And the example that I'm going to create involves keeping track of grades. So as a teacher, I have to of course, from time to time give homework assignments and quizzes and tests. I have to grade them, have to record them, and store them away somewhere, and that somewhere is in a spreadsheet. So you've probably seen the traditional green spiral-bound gradebook. When I was growing up as a kid, that was the standard way in which teachers kept track of their grades. And we're going to set up this spreadsheet in a similar fashion. We're going to keep track of the people with data down the leftmost column or down column A, and we're going to keep track of the grades that they receive in the subsequent columns to the right. So I'm going to put in some column headings here to make it easier to read. Now these row labels and column labels are useful as you're working with the spreadsheet electronically, but when it's printed, they don't print. So if you want some informational type column headings, then you're going to have to put them in yourself, so that's what I'm going to do. And I'm going to put in a column heading here in cell A1. So as I store data in the cells within a spreadsheet, the cells can be referenced by their column row coordinates, and you'll notice up here in the name box, as the tooltip suggests, I'm accessing cell A1. And I want to show you one other thing too while we're in the area. You'll notice that this area where name appears, and that happens to be the text that I've typed into cell A1, when cell A1 is active, then anything I type in is going to appear here. This is known as the formula bar. And the formula bar really serves two purposes. Number one, as I type data into a cell, or if I move away from the cell and then come back and point and click on it again, that cell data will appear in the formula bar, and if I need to make some kind of editing change, let's say I decide to, instead of call this name, I'll call it last name. If I want to make some kind of editing change, I can make the editing change through the formula bar. Here in a moment, when I introduce computational expressions, formulas and functions, we'll also see that the formula bar provides a place where I can look at the actual computational expression that has been assigned to a cell. So later on, again, when we look at these computational expressions, you'll see that the result of the computational expression will appear in the grid, and the actual computational expression can be seen through the formula bar. So again, two purposes: allows you to see the actual formula or function computational expression that's been assigned, and secondly, if you need to make any kind of editing change, it provides an area where you can edit the current contents of the cell. So I'm going to put in a column label in column A, and I'm going to expand the column widths, and there are a number of ways of doing this, but I'll show you one way at this point. If I drag on the dividing line between the column labels, it allows me to expand the column widths, and this time I'll put in first name. And then we're going to pretend that I'm a highly organized instructor, which requires a little bit of pretending, but we're going to pretend that I am, and we're going to pretend that I have decided in advance that I'm going to have 3 homework assignments, 3 projects, and I'll label the column headings P1, and I can either arrow over with the mouse by clicking, or I can use the directional arrow keys on the keyboard. Sometimes the directional arrow keys are even more convenient. I'll put in a column heading of P2, move over, and P3. So I have labels above the columns where I'm going to store Project 1, Project 2, and Project 3. And likewise, I'll have 3 quizzes, which I'll label the columns for them, Q1, Q2, and Q3. And I'll have 3 tests, T1. I get 2 tests, T2. Okay. Okay. I have 3. Doesn't matter. All right. Nothing magical about 3. That's why I was, debating whether to put 3 tests or 2 tests, was just to show that I don't have to have 3 projects or 3 quizzes. I can have any number I want. All right, and finally, in the end, I'm going to want to calculate an average, except I won't calculate an average. I'll calculate a weighted average, and then I will have the spreadsheet assign a grade. Notice I'm not going to put the letter grade in. I'll let the spreadsheet do that itself. So I have set this spreadsheet up. Maybe this is sometime in late August or something. I set up the spreadsheet. I'm going to highlight all the cells, beginning in cell A1 and extending through cell M1, or what I would describe as the range of cells from A1 through M1. And I'll go ahead and colorize them. I'll just go ahead and add a little yellow to accent them. And now the column headings are a little bit more visible. I could also come over here, try that again. Also go across there and add bold, do whatever I want to accentuate things. So there's my column headings, and now I'm going to again pretend that I am a highly organized person, and I'm going to enter in the names of my students. Now in actuality, what I do is I get the names of my students from the school's administrative system, but I could type them in if I wanted to. So I'm going to pretend that I have a person whose name is, first name is Moses. And what was this guy's name in reality? Name was, I know this, Horowitz, a famous person. And he had a brother named Samuel Horowitz. And he had another brother named, I'll come back to this guy. I had another friend named Larry, and his last name was Feinberg. And this other brother's name, famous brother's name, was Jerome. And there were a couple of other lesser-known characters. A guy named Joe. Besser. And all right, so we had Moses Horowitz, we had Samuel and Jerome Horowitz. Now, just something that's convenient here. You'll notice that the data that I've typed in into all of these cells is text data, or what we sometimes call string data type, or label data type is a term that's more frequently used among spreadsheet users. But if the data is of text or label data type, then I can copy it down this column in an absolute way. In other words, I could copy Horowitz to this cell and it would say Horowitz, and if I copy to this cell it would say Horowitz. And to do that, I click on the base cell, and then there's a little square over in the right hand corner known as a fill handle, and if I place the mouse pointer over the fill handle, the mouse pointer will change shape to a kind of a narrow crosshairs, and if I drag by the fill handle, it copies that base value in an absolute way into all the cells that I drag over the top of. So I've performed an absolute copy from cell A2 through A3 and A4. Okay, so there's the people in my class. This little feature here is of little significance here. It has some options, and I always hate this thing, so trying to get rid of it. It'll go away eventually. All right, so what I'm going to do is pretend that maybe I fill out the spreadsheet, maybe I save it. So if I click the icon at the on the toolbar up here, or if I go to the File pull-down menu and choose Save or Save As, regardless of what option I choose, it's going to bring up a Save As dialog box because this file is being saved for the very first time. Its location in the file system is not known until I provide some additional information. But the file will be saved, and I'm going to go ahead and navigate through the file system here. So I'll go to Drive C. It's the root directory of Drive C, remember. And I'll navigate through the folders: Chuck, AU, Fall 2013, 1050, and I'm going to create a new folder here, and I'm going to label this Week 2. So I'm creating these folders on the fly, and open that up. I'm going to save this as I call it Gradebook Demo 1. All right, so I've given it a file name, and it's going to save by default in the native, in this case, Office 2010 Excel file format, which has a .xlsx file name extension. So I'm going to save into the Week 2 folder, and now if I lose power or something, at least this much has been saved. So we're going to simulate what happens over time, and we're going to pretend that over time here I teach and give a project, and we're going to pretend that Moses, otherwise known as Mo, gets a 100. And in fact, it's such an easy project that everyone gets a 100. So I could type in 100, 100, 100, and so forth down each cell in this column, or again, I can use that same technique that I demonstrated before and enter the value into the base cell, then drag by the fill handle, and it will copy in an absolute way down cells C3 through C6. So everybody gets a 100, they're happy, and we fast forward, and we get a we have a first quiz, and as might be expected, Mo gets a 100, and then I notice a peculiar thing happens, and I'm going to show you a feature in Excel that's handy, but probably wouldn't be used, in this situation. But nevertheless, if you see how it works, you can apply it later on where it's applicable. But I noticed that something peculiar, that Mo gets a 100 and Shimp gets a, otherwise known as Samuel, gets a 90, and Curly, otherwise known as Jerome, gets an 80, and then Larry a 70 and Joe a 60. So it just works out that way. Now, if that pattern exists and I recognize it, one way that I could do it besides typing the values directly into the cells would be, I'm not dragging by the fill handle, would be to click on the base cell and then highlight from the base cell down through all the cells that are involved in this operation and go to the home page. So click on the home tab if necessary, go to the home page, clear over to the editing ribbon. That group of icons is placed in a kind of a grouping known in office terminology as a ribbon. And on the editing ribbon, there's a tool to fill with, and if you click on the down arrow, you've got several options to include series, and if I select series, it recognizes that I have these cells down a column highlighted, so it automatically fills in the radio button labeled columns, and it's going to suggest that I copy using a linear progression, and it's going to suggest that each value be incremented by a value of 1, which would cause Samuel to have a value of 101 and would have Jerome here having a value of 102 and so forth, but that's not what I want. So I'm going to change that step size to -10, and I'm going to say OK to that. And it automatically fills with the values that I described. So I show you the fill series. We'll come back and look at that later on when it's more appropriate to use it, but I just couldn't resist doing that at the moment. All right, so we have given a project, we've given a quiz, and then we decide to give a test, and as might be expected, Mo gets a 99, and Shimp gets a 89, and Curly gets a 69, and Larry gets a 78, and Joe gets a 71, making up some data. All right, so we've progressed into the semester to the point that I've given the first test, and I'll save just to make sure that that doesn't get lost. Now, usually when I give a test, what I do is I'll calculate an average. So I may want to come over here, skip a line, type in average, and calculate the average of all the test scores. And in fact, what I usually do is, if according to my grading scale, 90 to 100 is an A, and 80 to 89 is a B, and so on and so forth, and I figure the average grade for a class would be a mid-level C, which would be about a 75 according to that scale. And I calculate an average, and then if the actual average is lower than the calculated average, oftentimes I'll make an adjustment, okay? But I need to know what that calculated average is. Now, I mentioned before that we can store text type data called labels, okay? We can store numeric data called values, and we can also store computational expressions, and we're about to look at a computational expression, that expression being a function, a built-in function. Okay, so what does a function look like? Well, let me go over here to, again, the home page. You see the summation tool, and if I click on the down arrow, it shows me the most recently used functions, and then it shows me that there are more functions available. Now, functions are built-in expressions, so these functions are very easy to use. They're very reliable. They've been developed by the spreadsheet manufacturer, so they've been tested. They're very reliable. They're also documented extensively. So as a general rule, if I'm going to perform a calculation, and if there is a function available to perform that calculation with, I want to use a function. I only want to use formulas in instances where I have no other option, where that's my only way of performing it, where a function doesn't exist. So in this case, there are functions available. There is a function available to perform an average, and I can find it in the function library if I don't know anything about it by clicking on either all functions, or just because I've used this enough, I know that it's also grouped among statistical functions. In fact, there is the average function. Now, when I click on that, I told you these were documented extensively. It shows me the general form of the function, and if I've used this function before, or if I've used similar functions, that may be all the information I need. It's telling me the keywords average. It's telling me that inside of parentheses, known as the argument list, the components of data that it needs to work with are numeric values or cell values that translate into numeric values. Now, that may be all that I need, but if it's not, I can also click here where it says help on this function. And I don't want to sound like a salesperson for Microsoft. And in fact, many of the products that Microsoft makes, in my opinion, I'm just expressing my opinion here, have really substandard kinds of documentation help files with them. Excel's an exception. The help files in Excel are absolutely first rate, and you can drill down into this, get more details. They'll show you details about the syntax or the punctuation rules that are used to create the expression. And they'll also even show some concrete examples here, usually at least one, maybe more concrete examples. And seldom have I ever looked in the help files, read about a function that I didn't understand completely how the function worked. But if in fact that should happen, again, functions are documented extensively. Google for help on any of the Excel functions, and you're going to find out that there are at least a million different links to additional examples. Okay, so I may have exaggerated slightly, but the fact is there's no shortage of help on functions. All right, so I know how this function works, and I'm going to type in equal. Every computational expression, be it a formula or function, begins with an equal sign. So that's a syntax requirement or a syntactical rule. And then it's followed by a reserve word. If I'm creating a function, it'll be followed by a reserve word. And in this case, the reserve word is average, and that can be entered in either upper or lower case. And then what follows is called the argument list, where you list the data that you want to have the operation performed on. And I could type in the range of cells I2 colon I6. I could type that in at this point, or I can simply drag over them, and the spreadsheet program will do that itself. If I look up here in the formula bar, you'll see that it is written I2 colon I6. And then I close the argument list off, hit the enter key. It's calculated an average of 82.2. And if I were doing this in a real world situation, I would say, made the test too easy. Not going to make any kind of adjustment. So I'll save and continue on, and I give another project. Let's say that I'm making the projects way too easy, so Mo gets a 100. I can use the fill handle on the base cell and drag to the right. And then I can also drag down. Now I should introduce another term here. This highlight feature, this visual cue that marks the cell that I'm currently accessing, otherwise known as the active cell, is known as the cell pointer. So in the cell pointer, I have a embedded feature called a fill handle, and at this point, if I drag by the fill handle on the cell pointer, it's going to copy that base value in an absolute way. So there we have it, and let's say I give a quiz, and this time I really start to bare my fangs a bit with the class, and Mo gets a 66, and Shimp gets a 33, and Curly gets a 44, and Larry gets a 77, and I'll give this guy a 33 too. Okay, so there we have it. So the score's pretty low on that quiz, and some time passes. I give another test, and Mo redeems himself with a 98, and Shimp gets a 89, and who we got here? Curly gets a, I don't know, give him a 44. And Larry, we'll steady Larry there. And Joe, he gets a 44. So in case, you had some kind of sheltered childhood and were forced to watch public TV or something, you may not be familiar with this cast of characters. This would be the original Three Stooges. Actually, there's four. Mo, Curly, and Larry were the original Three Stooges, and Shimp took over from Curly when Curly had a stroke, and I don't know, this guy Joe Besser joined the ragtag team at some point later on. But these are the Three Stooges, or the cast of characters that made up the Three Stooges. Okay, so we're going to go ahead and give another project, and what the heck, I'll give a 90 on this one. Finally make a hard project here. Give an 88 and a 55, and just making up things, 77, 33, and give another hard quiz. We didn't take the average of this test, did we? So we'll find out what the average of this is. Okay, so I could type in equal average J2 colon J6, or I can go back to where I've calculated the average, drag by the fill handle, and this time it's going to copy that base value in a relative way. That is to say, because I'm copying a computational expression, a formula or a function, it will make adjustments as it copies. It'll copy in a relative way. If I copy across a row, it will change the column coordinates. If I copy down a column, it'll change the row coordinates. So as I copy across row 8, it's going to change the column coordinates from I to J, otherwise leaving the row coordinates alone. Now there's ways that I can override that, and I'll show how that's done later on, but the default way, at least, in which formulas and functions are copied is they are copied in a relative way where the row and column coordinates change depending upon which direction they're copied. Okay, so in this case, they got a 72, and I say to myself, close enough to a 75, I'm not going to make any adjustments. So I'm going to give another quiz, and I give a 100 and decide, you know what, I'm just giving everybody a 100, won't even bother grading them, I'll just give a 100. No, I wouldn't do that. But in any case, I did it here, and I copied that base value down, and now we're at a point in time in the semester where it's maybe going into finals week, and students getting a little edgy, and we'll pretend that Mo comes into my office, and let's not take Mo. take somebody else. Let's take, for instance, Curly. Curly comes into my office and says, my scores have been all over the place and I have no idea what kind of grade I can expect in this class. And if that were the situation, I would tell Curly, hey, let's do a little what-if analysis here. Let's try to predict an outcome from an incomplete set of data by entering in our best guess at what scores you might get. So we're going to look at maybe worst case scenario, best case scenario, and most probable case scenario. So for Curly, I say let's punch in a formula here, like the one I'm going to use to finally calculate your grade. And I'm using a formula. I'm doing a weighted average, and I'm going to weight your projects and quizzes at 40% and your test at 60%. So how do I do that? Well, I again have to begin every formula and function with an equal sign, and then thereafter I basically follow the rules of algebra, and especially in regards to order of operations, and where I might want to use parentheses to override the natural order of operations, I have to always use rounded parentheses. Another syntax rule regarding formulas and functions is that I cannot put in embedded spaces. If I'm doing this on paper, I might make it clearer to the reader by spacing things out a little bit. Here I want one character following another, no embedded spaces whatsoever. And some of my operators are a little different, so the multiplication operator is not an X, but rather a asterisk, and it must be specified explicitly. The division operator is a slash, and I think those are the major differences from just pure algebra. All right, so what do I want to do? I want to calculate a weighted average where I weight the average of the quizzes and projects at 40% and the average of the test at 60%. So I'm going to need to do three things to each component part. I'm going to need to add up all the quiz and project scores first, then divide by the number of quizzes and projects, and then multiply through times my weighting factor. And I need to do them in that sequence, which isn't necessarily the natural order of operations. So I'm going to have to force that order of operations by using parentheses. So within the interior set of parentheses, I'm going to add up for Curly on row 4, cells C4 plus D4 plus E4, and that gives me all the quiz scores, plus F4, which gives me the first quiz, plus G4, second quiz, plus H4, the final quiz, and I close that off, so it's going to perform the addition first within that interior set of parentheses. There's 1, 2, 3, 4, 5, 6 items that are in the list, so I divide by 6, close that off. That's done secondly, and that finds the arithmetic average, and I want to weight that average by multiplying through times 0.4, and that's going to add everything up, find the average, and weight it at 40%. And to that 40%, I'm going to do the same kind of thing over here with the test. I'm going to add up I4 plus J4 plus K4, the 3 test scores, divide by 3 items in the list, multiply through explicitly by 0.6, and strike the enter key. And I see that Curly has a 54, and Curly says, ooh, I didn't realize it was quite that bad. And I say to Curly, well, here's the thing. I calculated that using cell K4, and when a formula or a function references an empty cell, it treats it, I'm sorry, I'm going to correct myself here. When a formula references an empty cell, it treats it as though the cell has a value of 0. If a function references an empty cell, it ignores it. So a rule to keep parked in the back of your brain. Okay, so what I tell him is, another way of looking at this, if we want to do a little what-if analysis, is you're looking at worst-case scenario. So, you know, if you come in here and you get a 0, I'll explicitly put a 0 in there, hit the enter key, it still calculates to a 54.5, and you're going to fail. On the other hand, let's see, you got a 44 and a 69. Let's say that you get a 55, you know, just make up some number that's in between. Let's say you get a 55. Probably wouldn't have to study that hard. Hit the enter key. That's going to guarantee you a D. And, you know, that may be most likely case scenario. If you prepare like you did for the previous test, that may be what you end up with. On the other hand, if you study your brains out, you may be able to get a 100. And if you get a 100, this would be best case scenario, that takes you up to a mid C. So you could, you have within your power here to get anything from an F through a C, depending on how much, you know, you do, how well you perform on that third test. So that's the computational expression that I'm going to use to calculate the weighted average, and that wasn't really much fun typing it in. So I'm going to drag by the fill handle down, and that copies it into the other cells, copies it in a relative way, making adjustments to the row coordinates. And then I'm going to copy it the other direction, and again, that copies it in a relative way, making adjustments again to the row coordinate because I'm copying through the column. And so at that point, we pretend that we fast forward, and we go ahead and record some grades. And let's say that Mo gets a 90 finals week. He probably can't spend quite as much time. And Shemp gets a 87, and Curly, he changes his ways. He gets a 96, and Larry is pretty steady all the way across. He gets an 88, and finally Joe, he's kind of a slacker. He gets a 66. Okay, so there we have it. The final calculations have been performed, and you'll notice that once I put that computational expression in, then if I change any cell that's being referenced in that expression, the expression will automatically update itself. So it's a nice, convenient feature. All right, so here we are. We're at a point in time where we need to make some decisions. So I'm going to do this two ways. Let's say that we want to keep track of whether they pass or fail, and let's say that even though maybe it's a grad school course or something like that, where you have to get a C in order to pass. So even if you get a C, that's not a passing grade. You have to get a 75 in order to pass. Now, I could look over here at the cells in column L and determine the letter grade based upon the scale that I described previously, or I could have the spreadsheet program perform that calculation for me. And what I want to do is demonstrate now how a spreadsheet program can do that using a logic function, built-in logic function known as the if function. And this can be written a couple of different ways. First way I'm going to do it is the simple, straightforward way where it makes a two-way decision. And what I want it to do is examine the contents of L2, and if it's greater than or equal to 75, I want it to display the string literal, just the message that reads pass, and if it is otherwise, I want it to display a message that says fail. So how do I do that? I'm going to use a built-in function. All functions and formulas begin with an equal sign, and then functions begin with a reserved word. In this case, the reserved word is if. And the if function, if I look at this information that pops up here, has 1, 2, 3 arguments. The first argument is a logical test or a test that evaluates true or false. And in this case, I want to take a look at L2, and the test will be L2 greater than equal 75. Comma. I separate these arguments with commas. So that's my first argument, the logical test. As soon as I type in the argument, the IntelliSense, as it's known, advances here. And now it says value if true. So this is the true path. What do I want to have display if it's true? If it's true, I want to display the string literal paths. When I hit the comma, value if false, this is the false path. If it evaluates false, I want it to display fail. And I have to surround those string values with double quotes. And I close off the argument list, hit the enter key, and as expected, Mo passes. But if I drag on the fill handle down, it's going to copy that function in a relative way, changing the row coordinates because I'm copying down a column. And we're going to see that, as would be expected, Joe Besser fails, and so does Curly. Okay, so that's an example of a if function being used to make a decision. Now, if I were to go back, if Joe comes in and says, hey, you know, look, regrade my test, and I say, what the heck was I doing? You got a 100. If I hit the enter key, his grade's going to shoot up to a 75.8, and because that cell is being referenced by this function automatically changes, and now he's got a passing grade. All right, how do we make a letter grade assignment? Well, I have multiple decision points here. You know, it could be I got to check to see if it's an A, I got to check to see if it's B, a C, and a D. So there are 5 possible outcomes that I need to test for, and therefore what I need to do is build into this 4, or n-1, number of outcomes minus 1, decisions. And the way I'm going to do this is to put decisions inside of decisions. I'm going to nest these functions, and I will create a nested decision structure that looks like this. Equal if, I'm going to test for an A first, and I'll be checking, in this case, L2. So if L2 greater than equal 90, I want to assign an A, that's the true path. If it's not an A, it could be a B, could be a C, could be a D, could be an F. There's still more decisions to be made. So if it evaluates to an A, it'll assign an A and be done. Otherwise, it'll skip the true path and go to the false path, where I'm going to put another if function in. And this time, check to see if L2 greater than equal 80. And if it is, I'm going to assign a B. And if it isn't, it will take the else path or the false path with respect to this second if, this nested if. And I'll need to make a further decision to see if L2 greater than equal 70. And if that's the case, then I'm going to assign a C. And if it's not the case, it could still be a D or an F. So I need to make one more decision. If L2 greater than equals 60, if that's the case, then I'm going to assign a D. And if I have not assigned an A or a B or a C or a D, at that point the only other option is to assign an F, and I don't need to make a decision. I just go ahead and put that on the false path in regards to the last if function. And now I have to close off all these functions. So the first parenthesis is going to correspond with the opening parenthesis on the argument list of the last if. Then I need to close off 1, 2, 3 more. And once I've put all the closing parentheses in, hit the enter key, it comes back and assigns an A to Mo, which I would expect. And if I drag by the fill handle, it assigns grades, and that one's the interesting one because although he gets a C, it requires 75 to get a passing grade, and he still fails. Okay, so there you have it, an explanation of how a spreadsheet works. So we know that the spreadsheet has storage locations at the intersection of columns and rows, and those storage locations are referenced by the column row coordinates, and that we can store text, otherwise known as label or string. We can store numeric values, otherwise known as values. We can store computational expressions that may be of the type that we create ourselves, formulas, or they could be of the built-in variety, they're really the preferred variety, if at all possible, known as functions. And you know, we have a few other just things about the spreadsheet you should be aware of. You got the cell pointer, which you can move around and access individual cells with if I need to put values in, change values, whatever I might want to do. So the cell pointer marks the active cell. The cell pointer has a fill handle that's used for copying. When I copy, it'll copy in an absolute way or a relative way depending upon what is being copied. And then of course I mentioned the formula bar up here, which is used to make corrections. Okay, so let's say that I change my policy over here and no longer is a 75 required to pass, but rather a 70. So rather than having to retype that function, I could go back to maybe the first occurrence of it and change the 5 to 0, make a little fine-tuned correction there. I always click at the end of the function and hit the enter key, and that actually records it. And now if I were to fill down, it will fill in a relative way, and turns out at this point that good old Curly passes and doesn't fail anymore. So that's a quick look at how spreadsheets work, and we'll come back and take a look at another spreadsheet example in the next module.